Good day and good evening, everyone. Have you ever wondered how Java keeps things organized, efficient, and usable? Well, today we're diving into the world of Java packages, the secret ingredient that helps developers manage their code effortlessly. In this video, we will present a discussion on Java packages, including their definition, purpose, types, creation, building and working with Java packages, and lastly, we will cover key takeaways. Let's get started.
Hi everyone, I'm Christine Lara Ocomen, and today I'm going to explain what are Java packages and the types of Java packages. So without further ado, let's start about what are Java packages. So what are Java packages? Java packages are namespaces. It is ways of giving things unique names to avoid confusion, like giving each book a unique title and author. They group related classes and interfaces to keep your code organized. Imagine a huge library. You wouldn't search randomly, right? You'd go to the history, science, or fiction section. Java packages are those sections, keeping related classes together. If they are in different packages, there are no conflict. The compiler can distinguish them by their full package name. So what are the purpose of Java packages? Packages serve three main purposes. First, avoiding name conflicts. Imagine two different authors writing books with the same title. Hindi ba nakakalito siya? But with packages, we can prevent this in Java. Two different packages can have classes with the same name, because the package acts like the prefix to the class name, distinguishing them. For example, group.cc103 and Ocomen.cc103. They are both completely different classes, even though they share the name cc103. Second, controlling access. Packages control access to your code, just like librarian control access to the library catalog. Java access modifiers public, private, and protected work with Java package. Java's access modifiers public, private, protected work with packages to determine which part of your code are visible to other parts of your code and even to external programs. This ensures that sensitive code remains protected. And third, encapsulation. Packages promote encapsulations, which means bundling related things together. This makes your code more organized, easier to understand, and easier to maintain. Packages make it easy to find and use Java classes. So let's now proceed to the next part, the types of Java packages. Let's expand our library analogy to understand the different types of Java packages. Remember, Java packages organize related classes and interfaces. But where do these packages came from? There are two main types, built-in and user-defined. So first is built-in packages. Think of built-in packages as core collection of books in your school library, the essential text everyone needs. These packages are part of the Java Development Kit or JDK, which is the software you use to write and run Java programs. They provide fundamental classes and interfaces for common programming tasks. Some examples: java.lang. This is like a reference section of the library, containing essential classes that are automatically imported into every Java program. It includes classes for basic types, like integers, string, system-level operations, and more. You don't need to explicitly import this. They are always available. Next example, java.util. This is like the helpful tools section, containing classes for data structures like array list, hash map, date time handling, and other utility functions. You'll use this frequently in your programs. Third example, java.io. This is the section with books on input and output, providing classes for reading and writing data to files, network, and other sources. Many other built-in packages exist, each offering specialized functionality. They're pre-built and ready to use in your programs. So the next type of packages is user-defined packages. Now, imagine you want to organize your own collection of notes or research paper or book collection. That's what user-defined packages are in Java. These are packages you create yourself to organize the classes and interfaces you write for your specific projects. They provide a way to keep your code clean, modular, and reusable. For example, if you're building a game, you might create packages like christine.mygames.characters or christine.mygames.weapons. And of course, you need levels, right? So, christine.mygame.levels. This keeps all classes related to characters separate from weapon classes, making your code much easier to manage and understand, just like having separate folders for different research topics. So in summary, built-in packages are the pre-made tools provided by Java, while user-defined packages are your personalized organizational system for your own Java projects. Both are crucial for writing well-structured and manageable Java code.
Now let's move on to creating a Java package. So to better understand this concept, we will demonstrate how to create a Java package in Eclipse. Now, after opening Eclipse, to create a Java package, click on Create a Project, or you can also click on the file in the top left corner. After that, select Java Project, enter a name for your project, and click the Finish button. The project folder will then appear in the left sidebar. Click on it, then click New and select Package. Finally, name the package and click Finish. And there you have it, a Java package. Simple as that, but sorry for the screen recorder watermark. Now let's go to the building and working with Java packages. So first is built-in package. So Java comes with several built-in packages that are included in the Java Development Kit or JDK. So these packages contain pre-written classes and interfaces that provide essential functionalities, so making it easier for developers to write programs without having to code everything from the scratch. So how do they work? So built-in packages help streamline development by offering commonly used tools and utilities. For example, the Java Lang package provides fundamental classes for handling basic data types, mathematical operations, and system input and output. Similarly, the Java Util package includes utility classes that assist in working with collections, dates, and random number generations. Since these packages are automatically imported into every Java program, developers can use them without needing to write additional import statements. So later on, someone will gonna show us or demonstrate us how these packages work in Eclipse. So for example, one commonly used class from Java Util package is ArrayList. The class provides a resizable array implementation unlike regular arrays that have a fixed size. So with ArrayList, developers can dynamically add, remove, and manipulate elements efficiently, making it valuable tools for handling collections of data. Next is the user-defined packages. So in addition to built-in packages, Java allows developers to create their own packages known as the user-defined packages. So these custom packages help organize code into logical groups, making large projects easier to manage. So they also help prevent naming conflicts by keeping related classes and separate namespaces. So in simple terms, user-defined packages are folders that developers create to organize their Java code into groups. So how do they work? To create a user-defined package, developers must declare it at the beginning of a Java file using the package keyword followed by the desired package name. The package name should match the directory structure where the file is stored. This ensures proper organization and accessibility of classes within the package. For example, if a developer creates a package named com.example.myapp, the corresponding Java files should be placed inside a directory structure that follows this hierarchy com/example/myapp/. So this setup ensures that Java recognizes and properly locates the package and its contents, allowing developers to import and use the classes within it efficiently.
Here are the 5 steps on how to create Java packages in Eclipse. Number 1. Create a new project. In Eclipse, start by creating a new Java project. Number 2. Right-click on the src folder or any source folder and select New Package. Number 3. Name the package. Enter the desired package name. Follow the convention of using lowercase letters and dots to separate segments. Always remember that Java is a case sensitive. Number 4. Create classes. Right-click on the newly created package and select New Class to add Java classes to your package. Number 5. Package Declaration. Eclipse automatically adds the package declaration at the top of each Java file you created within the package.
Hello mga ka-IT! Today is the day that I will demonstrate you all how Java package built-in function. I'll demonstrate it in a detailed way. First thing first, we need the import. Import allow us to use pre-built Java classes and methods in our program. And just add the Java, the util array, this. The Java util is a package that contains various utility classes including ArrayList. Secondly, let's create the main class method, which is the public class main. Public class main, this declares a class name in Java. The name of our Java is built. And square root on it. Then let's add a public static void main inside the public class, because public static void main, this is the entry point of the program. And let's add the string square bracket args and square bracket again, string array or string args. This is an array that can store command line arguments if providing when running the program. And the third step is creating an array. Let's create an array inside this public static void main. Array list string. Array list string. This means we are creating an array. Will store string values text. The cars. Cars, this is the name of array list used as variable to reference the list. And let's add an item to our array list, which is ars.add. This syntax is a method to add an array list let's have 4. The name of our cars is Lamborghini, GTR, BMW, and Mustang. And lastly, we're gonna display an array list, which is through this method, system out dot print line. Yan. Then we're going to call a variable name of our array list to put inside of our displaying syntax. And let's run it. And this is the output of the Java build package. Let's move forward to the second type of Java package, which is the user-defined package. Let's do it. This syntax or this code defined as a class name in Java. Every program must have a class. And second method is the adding integers, the public, static, int add, parentheses, int a, and int b. And put a curly bracket and return a plus b semicolon. The third step is the main method, which is the public static void main, and the string square bracket args, and put outside of parentheses the curly bracket and the variable of the main method, which is the sum. This one, the sum, is equal to add 5 and 3 and semicolon, and the system out we're going to display the main method or the result of our adding integers. But we need to fix this. No. The sum is, we're going to put the variable which is the sum. It's already connected, and the semicolon. And let's click the run build to show the output of our user-defined package. Let's do it. The sum is 8. Ta-da!
Here are the 3 key takeaways of this lesson. Number 1, package organized. Packages structure code by grouping related classes together, enhances code readability and maintainability, making projects easier to navigate and understand. Think of it like organizing a library. Books on similar topics are shelved together for easier retrieval. Number 2. Avoid conflicts. By placing classes within distinct packages, the risk of naming conflicts is significantly reduced. This is crucial in larger projects where multiple developers might independently create classes with similar names. Packages provide distinct namespaces, ensuring that each class has a unique identifier. Number 3. Code reuse. The modular nature of packages promotes code reuse. Well-designed packages encapsulate reusable components, which can be readily incorporated into multiple projects. This reduces development time and effort, fostering consistency and efficiency across different software systems. Essentially, it's like having a pre-built, reliable modules that you can readily integrate into your projects. That's all. Thank you for listening.